Welcome to solverfy.
So the sum of the object and image distance, so from object O to image IA and image IB, so for both the drawing on the left and the drawing on the right, that distance is labeled dt, and it's the same for both. And we're told that this is equal to 86 centimeters. So we're going to solve this relationship for the image distance and use that expression in equation 23-8 in order to find the distance to the object here. So first, we're going to write out the fact that the distance to the object plus the distance to the image is going to be equal to the total distance d sub t. Okay? Therefore, the distance to the image is equal to d sub t, the total distance, minus the distance to the object. Now, we can use the formula that says 1 over the distance to the object plus 1 over the distance to the image is equal to 1 over the focal length. Now we can plug in the distance to the image that we found above. This gives us 1 over the distance to the object plus 1 over the distance to the total distance minus the distance to the object. We're just replacing that distance to the image with that expression is equal to 1 over f. Okay? Now we can subtract the 1 over f to the other side. So let's just go ahead and do that first. So we're going to subtract that over. So this is minus 1 over f, and that's equal to 0 now. Okay? Then if we multiply through by f, and we multiply through by d0, and then we multiply through by dt minus d0, so we're just getting all of those out of the numerator, we find that this is equal to d0 squared minus the total distance, dt, times the distance to the object, d0, plus f, the focal length, times the total distance, dt. This is equal to 0. So in terms of using the quadratic formula, we find that d0 is equal to dt plus or minus the square root of dt squared minus 4 times 1 times f times dt all divided by 2 times 1, which is just 2. So plugging in the value for the total distance as well as the value for the focal length, which we were given, we will get two different values because of the plus minus. One of them is 21.3 centimeters, and the other one is 64.7 centimeters. So one of them is for that first image that I drew, and the other one is for the second image that I drew. We can box that in as our solution to the question. Okay. Also note that to have real values for the d0 or the distance to the object, we must in general have dt squared minus 4 times f dt be greater than 0, or dt, the total distance, be 4 times greater than the focal point. And that's because of that square root value there. If that was a negative value, then we would end up with imaginary numbers, which we don't want.